Hey everybody, I'm your host, John Myers, live from Stillwater, Oklahoma. We have got a great show tonight. It's John Myers. Hey everybody. Gotta have my notes. It's John Myers from the Kicker UnMasked studios. Gotta have my notes. Alternator. Hey everybody. We have fun. Hey everybody. Hit like and subscribe. Right here, right now. It's John Myers. We like to give stuff away. Alternator. Post some more pictures. We gotta thank Steve and Becky live from Stillwater, Oklahoma. Don't forget Texas Roadhouse right here, right now. Hey everybody. Don't forget right here, right now. We have got a great show tonight. Hey everybody. Had a great dinner tonight. It's John Myers. Right here, right now. Had a great dinner tonight. So, hey everybody. So, housekeeping. Had a great dinner tonight. So, alternator. Housekeeping. Housekeeping. So, Tuesday night. Housekeeping. From the Kicker UnMasked studios. Housekeeping. Right here, right now. Hey everybody. So, it's John Myers. Hey everybody. It's John Myers from the Kicker UnMasked studios. Hey everybody. From the Kicker UnMasked studios. It's John Myers. Right here, right now. We have got a great show tonight. Hey everybody. We have got a great show tonight. It's John Myers. Hey everybody.
Right here.
Good evening, ladies and gentlemen. This is Aaron with the Kicker Tech Force coming to you live from the UnMasked studios. It must be Tuesday at 7:30. It is August, very end of August, like the 30th or something like that. And we've got a fantastic show tonight. As you're probably already aware, we have Mr. Joe Hobart coming in to guest with us again tonight. He was so popular the last two times we had him on. You guys and girls said, hey, bring him back. Drop some more science on us. But here tonight in the studio, we've got Mr. Birthday Boy, JW. Yes, he is 29 again. We had a fantastic meal, and for those of you that care, we did have Texas Roadhouse because that's his favorite. We also had some cake. We had some delicious cake, and I think we got a picture. Yep, there we go. There's the cake. Almost caught the chops on fire. They were supposed to be sparklers, but they didn't really sparkle. They just blew out. But anyway, we've also got, of course, Bill Frog, working the keyboard magic, and Ernie, who will never be on camera. He has sworn never to come in front of the camera. He likes to be behind the camera because he's just that attractive. So that's our show tonight. We're going to take a couple-minute break. We're going to get Joe here on set, and we'll be right back.
It's been a long road since the original Kicker christened that first pickup truck. It kicked off a car audio renaissance, and upgrading your music in a vehicle was a requirement. America's music machines became living loud over your passion, your emotion, your existence. Outdoors or on the open road, your sound is Kicker.
Welcome back. Thank you all for being here. Mr. Joe Hobart. Joe, for those of our audience that haven't yet met you, who are you and what do you do here?
Well, here I am Director of Electrical Engineering for Stillwater Designs. My background comes from everything from vehicle integration back in the early days of iPods and OnStar and that fun stuff to amplifiers and DSPs and all the fun things we do now.
So you're basically responsible to make sure Mr. Irby's vision turns into a product.
Yes, completely from start to finish when it comes to electronics. Yes.
So you get the cat herding responsibilities of the electronics group.
Electronic janitor, yes, yes. Get to clean up all the mess at the end. That's my job.
The ultimate responsible man right here, right? So the last couple times you've been on, we talked a lot about amplifier topology, we talked about power supply designs, and one of the things we never got to was the half bridge versus full bridge and what the differences are. And we were talking at dinner and you said one is not better than the other. There's just differences and the way you implement the design makes a big difference. So we want to talk about that. And what else are we going to cover?
Completely. You hear the argument all the time, half bridge, full bridge, one's better than the other, one's cheaper than the other. In reality, it comes down to more of how you do the layout, what parts you choose, how you implement the technology. Tonight we will be testing actually two completely different type of half bridge amplifiers, and you'll see the results are completely different, even though they're the same technology. It really comes down to layout, parts choice, and that's the main things, right? And so unfortunately, when you're rushing to get to market or when you're cost constrained, right, you can't always choose maybe the parts that you want and have to make sacrifices. And then everybody holds their products to different levels of quality or performance. And so you end up with different things. There just happens to be that there's a lot of Brazilian designs out there that use half bridge technology, and so that's kind of become the standard for half bridge. But the truth is probably about half of our amps are half bridge.
Okay.
And same thing with RF, JL, take your choice. A lot of the amplifiers are half bridge. Easy way to know if they're half bridge is if you can bridge an amplifier, i.e. a multi-channel amp, and it's bridgeable, that's a half bridge amp.
So a bridgeable amplifier is half bridge by nature.
Yep.
Okay, so like our KXMA 1202, it's a 1200 watt stereo amplifier. It's not bridgeable.
Yep, because it's already bridged. That's why it's called a full bridge, right?
Full bridge.
And what happens with that is in a normal half bridge amplifier, you have one of the positive negative leads drive the speaker. And it could be either or. So if you take a meter and you check from the positive to ground when the amp's off and from the negative to ground when the amp's off, if one of those reference ground, it's a half bridge. Okay. If both of them have high impedance, say 5K, 10K or up, it's a full bridge amplifier. And it can be flipped because when you're using a split rail power supply, when you're driving one speaker positive, you'll be on the positive on, say, this right front, the positive lead's actually the output, but on the left front, the negative would be the output. So it can be a little confusing because you're driving it in the opposite direction out of phase, but it also actually drives the speaker in phase because it's on the negative speaker line.
Okay.
So it is a little confusing when you're trying to check for them, but...
well, and why would someone want to check for it? Why would it matter?
To be honest, there really isn't a reason it would matter. It's really if somebody wants to know what they have.
Okay.
Otherwise, both can perform really well or both can perform really poorly. It just depends on how they're laid out and done.
Okay. So you've got a whole list of things we're going to talk about. What are the other things?
So tonight we're going to do some amp dyno testing, which I know everybody likes.
Yes.
And then after that, we're going to switch over and do some audio precision testing to do what I call, like, if you're old enough to remember Paul Harvey, the rest of the story.
Yes.
Right? I remember my parents listening to that all the time as a kid. And now the rest of the story. Well, that is what we're going to do tonight. We're going to do some amp dyno testing on two different types of amps. Then we're going to go down and we're going to pull the other stuff. And so here's some of the other stuff that we're going to test that really matters to a consumer because it helps either in your install, gets rid of the in the background that you're hearing, or allows you to have the same power across the whole frequency response. So those are tests that really actually go towards the bottom dollar. There's a bunch of other tests that we do for performance stuff that's a little more tweaky. These 4 tests are really meat and potatoes. This should always be done. You should pass these type of tests.
Okay.
This is what they're for. And so the first one's going to be SNR, signal to noise, and that is the noise that you're talking about, that white noise in the background when you turn the gain up, right? This test will show you what the signal to noise is of that amplifier, and it'll be shown in a number, so it'll be like 70, 80, 90, whatever the number is, right? And that means that's 90 dB between the noise floor and your signal, or 60 dB or 40 dB, right? Whatever it is.
So the higher the number,
the better it is, right? You'll see like esoteric amplifiers will usually be in the 90s, 85 to 95, maybe even 100 in some cases. But that's like the really like 2,000, 5,000, 10,000. Like
Sure.
they spent a lot of time trying to get the noise floor way down, which in home makes sense.
Yes, and once you start the car and drive.
Yeah, once you start the car,
it's gone.
right, after you get past like say 90, it kind of becomes like, well, yeah, the car's louder than that, and so you can't really tell the difference.
Okay.
The second thing we're going to do is a CMRR test. And instead of going into what CMRR is, it's common mode rejection. But what it really does is it's the ability of the amplifier to reject unwanted noise on the inputs. So switching when you turn your lights on and off or lock your doors, engine noise, all those weird clicks and pops that you can get in a car, alternator whine, all of that stuff. CMRR, the higher the number, the better chance you won't have engine noise, right? Or any of those other noises. And so we're going to do that test of these both amplifiers tonight as well. The other test we will do is power versus THD. That's total harmonic distortion. It is different than SNR. As SNR is constant, THD changes with the power output level. And so we'll be doing a sweep of that, so you'll be able to see the THD across the whole power bandwidth as it goes up. And then at the end of that, you'll see where it crosses 1%, which is where industry-wise, according to CEA and what most of us do, 1% is where you rate your power of your amplifier at, right? And so you'll see that.
So the THD, the quality of parts and the design of the board will help determine your THD.
Completely, and to be honest, it's probably 70% layout, 30% part choice. Unless you're a DSP-based amplifier, and then the better D to A's and DSP will help raise that floor, right? Because your signal noise is going to be as bad as your worst part, right? And so as long as you have good parts, then THD and signal noise can be higher, but layout is the key.
So when you go to ampguts.com or whatever the current website is, and they show all the amp guts, and you look at them, you can say, okay, this is going to be noisy, this one's going to sound great, this one's going to blow up.
Not always, but in a lot of cases, yeah, because there's certain rules that you want to try to follow, right? The first one is like power supply, caps and FETs and all that stuff need to have big traces, be close together, be short runs. You'll see amplifiers where like the power wire or signal wires are jumped all the way across, right? You know, and so those ones you can kind of tell there's going to be some issues. Or if you see there's a power supply inductor in one corner of the board and there's one FET on that side and then another power supply FET all the way on the other side, it's going to have issues, right? Or at least reliability issues, might have performance issues. So you can kind of start to look, when you start looking at amplifier, going, okay, yes, this was done very cleanly. The signal's separated from the power. The ground has a great plane. Now, when you get into more complicated amplifiers that have been squished for size, say like the Key product, that type of stuff, there's internal ground and power layers that you can't see. So it gets to become very hard just to like look at something and go, yes, this should be good or bad, because most of it's hidden.
Okay.
The last test we're going to do is power bandwidth. And to be honest, this is the one. The amps we will be testing tonight are not the amps that I intended to test when we started talking about this earlier last week.
And why is that, Joe?
Because I've gone through 6 amplifiers at this point.
What do you mean gone through, Joe? What does that mean?
I've had 6 competitor amplifiers let smoke out. So the power bandwidth test is a CE test as well. It's a consumer CTA test, 2006 CE now. And their goal is basically you sweep from whatever you say your frequency response is. So 3 dB down on either end. The lowest point is your frequency response. From there to there with 60 points, and it takes a minute. And the lowest power in that point is your rated power, is what it's supposed to be. Some amplifiers don't survive this test. I've shortened it to like 20 points, so it's much faster. And as long as we leave these half-bridge amplifiers only running 2 channels and in stereo mode, they survive.
2 channel, so there are 4 channel
They're 4-channel amps. We're only loading half of them for these first tests tonight because we want to get through the tests.
Without damaging
them because I'm out of amplifiers. If we have time afterwards, I'll redo them and put them in bridge mode and we'll see what happens.
Okay, so hold on. Now, he said if we have time, we will burn stuff up. That's what Joe just said. So we're going to make sure we have time.
Okay. And that is the 4 tests we're really going to be doing. We need to talk a little bit about how the amp dyno does its test. I believe we have a graphic for this.
Oh, you want to do that right now?
Yeah.
Okay.
Yeah, there it is. Ernie got it up.
Oh, nice.
So if you look at this graphic, this is the track 9 or track, I think it's 4 for the subwoofer one, of the certified and uncertified amp dyno test. And what they do is they basically have a 10-second track that starts at negative 25 dB in output ratio, gain, right? And goes up to -5 dB at the end. Now, to understand why it does that and how they do their things, we got to back up a step. So when you set up the amp dyno, you set it up where you get the head unit up to clipping, down one step. Then you go into the amplifier and you set 10 dB of overlap with the gain knob and get into clipping. So what that allows you to do is with this setup, you have 5 dB of overlap for that last like 2 seconds maybe.
Okay.
So as this track plays, you'll notice on amp dynos when you watch the videos, the number climbs, and then stops, right? That's because the track continues to get more amplitude in it.
Okay.
And as it goes up, at the last couple seconds, you have that 10 dB of overlap, but you have a -5 dB track. So you really have 5 dB of overlap.
Okay.
And that last 5 dB gets you into up to 1% or into clipping, right?
Okay.
And that's where you get your numbers from. Dynamic test is done a little different. They have a little pulse track that pulses. Same idea. It's like 2 seconds long, 1 second long, and it just pulses and you get the number. But tonight we'll be doing certified and testing only.
Okay, so we're going to show what the amp dyno can do, and then we're going to show what the AP can do.
Yeah.
So they both have their place in the world of car audio, but they have a different place.
Definitely. The amp dyno is a great consumer tech tool. It's great for YouTubers or people that want to do basic testing.
Sure.
The drawback with the APs is, one, you have to understand the test and know what you're doing and set up the GUI to be correct, whereas the amp dyno kind of walks you through it.
Sure, simple,
and two, you have to get your own loads and get your own power supplies and get it all set up and make it work, where on the amp dyno, you're just literally getting batteries or power supply, walking through their process and going. It's much more straightforward. It's simpler to use. It's kind of like those cars plugins you can get for like dyno and horsepower numbers and quarter mile number you take it on your dash, right? They're a good way to measure something. They're not always 100% accurate, but they give you a good idea of what you're doing versus if you run stuff back to back to back. You can kind of get a good idea of how it performs.
And the cost of entry for both products?
Well, $3,500 for an amp dyno, and the APs for the good ones with all the extra features that we have are anywhere between 10 times that to 15 times that, right?
Yeah.
So it's a much more expensive entry into play.
But because we design and build amplifiers,
they are the industry standard. It's what we use at every factory. It's what we use in house. It's what all of our main competitors, JL Fosgate, those type of guys use. It is the go-to part. Same thing with home audio. Everybody uses Audio Precision to test. It is literally the golden reference standard.
Okay.
For us.
All right. So anything else, or you want to run back to the lab and?
Yeah, I think I need to get in the lab and we'll go from there.
All right, so Joe's going to run back to the lab, put on his headset, and we're going to talk about some new speakers we just introduced. So go ahead, Joe.
Yep.
So we just introduced in the last few weeks our new PS, which is Powersports Harley-Davidson specific 5x7 speakers. And as the model number suggests, these are specifically designed for Harley-Davidson. About 2014 and up, if they have a factory installed 5x7, this is a direct OE replacement, original equipment. That means you can simply take out the Harley 5x7, drop in the Kicker 5x7. It has the same plug. You probably, I guess we don't have another camera tonight, Ernie, right? So we've got a plug right here that allows us to plug into the factory Harley harness, click, and then you just run in the 4 screws, put it back together, and you've got upgraded sound. So it's a very simple upgrade for the Harley-Davidson customers. Now, a couple of key things to understand about these speakers. If you're looking at it, you're looking at the back here, and you're saying, man, that's a really tiny magnet. Well, I'm guessing that the smart guys and girls in the audience, you have an idea of why that magnet is so tiny, because it's made of neodymium instead of the more traditional ferrite magnets or the strontium magnets. So neodymium is very, very powerful, even though it's in a very small package. Now you'll also notice, again, I don't have a close-up camera today, I'm sorry about that, it's in the lab with Joe. There's actually a heat sink wrapped around the neodymium magnet. And the reason there's a heat sink is because neo does not like to get hot. In fact, if neodymium gets too hot, it actually loses its magnetic properties, and then of course your speaker doesn't sound very good, or it just fails altogether. So we've built in a heat sink to keep this thing running cool. Now, why would we be using neodymium in a speaker? Well, because of weight. We want the speaker to be as light as possible. When we first started making Harley-Davidson speakers, probably 7 or 8 years ago now, our PS5250 was our first Harley-Davidson speaker. We learned a lot of lessons from Harley-Davidson. One of those lessons was, do not add weight above the center of gravity or on the fairing. Do not add weight to the fairing. Well, why wouldn't you want to do that? Remember when you were a kid and you were riding your bicycle and a friend of yours was sitting on the handlebars of your bicycle? Remember how that bike changed its riding dynamics pretty dramatically? Well, that same thing happens on a Harley Davidson when you start adding weight to the fairing. So if you put a big, beautiful, great sounding speaker with a monster magnet that weighs a lot in the fairing, you just change the way the Harley handles. So that's why we're using a very small, very light neodymium structure. In addition, we're using a composite basket, so it's lighter and strong like steel, but lighter. Also, it is waterproof, the basket itself. Once the speaker is installed, it is weatherproof. So if you need to hose down the bike or get some moisture on it, some dirt, dust, mud, whatever, it's not going to damage the speaker. You'll also notice that tweeter is aimed slightly forward and up. That's because when this speaker is behind you in the saddlebag, we want to aim the high frequencies towards your ears so it cuts through that wind. Now, hopefully you're wearing a helmet when you're riding your Harley. So these speakers are specifically voiced to cut through the helmet and the wind noise and the pipe noise so that you can still hear the music loud and clear like you'd expect from Kicker. So a lot of design went into these speakers to make them sound fantastic and be a simple upgrade. There's also two options in impedance. There's a 2 ohm and a 4 ohm. The simple difference is the 2 ohm, if you're using just a pair of these and you've got a 2 ohm stereo amplifier, you'll get more power out of the amplifier running the 2 ohms. If you're replacing the factory speakers, which are 4 ohm, but you're not upgrading the electronics, then you want to put in the 4 ohm version so you don't load down that factory electrical system and the factory radio. So these have just been released. If you got a Harley Davidson and need a 5x7, check these out. You're going to like them a lot. Is Joe ready to go back there? Okay, I'm going to put on my lovely headset here. Can you bring up Joe? Yeah, here we go. Joe, can you hear me?
I can hear you, Aaron.
Excellent, excellent. I like that headset. Now you look like Gloria Estefan.
Gonna get ready to sing a ditty for you.
I can hear Ernie laughing in my ear. Can the audience hear you laughing, Ernie? Yeah, okay. All right, Joe. So tell me when you're ready to go and what you're doing.
Okay, we are ready to go. We will be testing the competitor amp first with the amp dyno. This is 2 channels of the amplifier, not all 4. Like we said earlier, this is not something we would normally do, but I'd like to get through testing tonight so you guys can actually see these tests without this thing being, shut off early. So testing 2 channels of 4 ohms. Originally I had similar powered amplifiers. Unfortunately, the 3 samples that I had are gone. So this amplifier is actually about 100 watts, a little more than that, more powerful than what we're testing of our amp. But you'll get an idea as we go through this. All the process is all the same. All the results show the same things. You just get to see them. So we'll do amp dyno first here.
Okay, so just so we're clear, Joe, you're going to use some competitive amplifiers, but we're not going to talk about the brands because that's not what we do here at Kicker.
Nope.
And we're not trying to disparage the brands. We're simply showing their design and execution versus ours and let the audience do their own conclusion.
Yeah, this is literally just showing the differences between the 2 designs, and in some cases kind of give you an idea of why sometimes you get what you pay for and sometimes you don't, and this is just kind of one of those things. But yeah, we don't want to talk about any in particular, that's why it's hidden.
Okay.
We're just going to show numbers and that's it at this point.
Okay, great. Thank you, Joe.
Okay.
Take it away.
All right, so we're going to start the amp dyno on the competitor test first. This is going to be a 4 ohm test. So if you close up in here on the amp dyno, you see we're going to choose 4 ohm. It's already in stereo. We've already set up the gain for everything. So I will click go here and hit go on the track. There you got signal. Power should start climbing.
So on the left, I see channel 1, channel 2.
Yep. So you've got 284 and 269, if somebody would write that down.
Oh, someone back there got a pen and paper? Actually, okay, hold on, Joe. Ernie's getting his pen and paper together. He's also dropping his headset on the floor, stepping on it.
Okay. So it's gonna take me a second. I gotta switch loads to the other amplifier because we're only doing the amp dyno first here. Get it out of the way. It's kind of the easy test on the amplifiers, so I want to get that done first.
So the first amplifier you did was the brand we're not discussing.
It's rated at 1200 watts, so it's a large 2-channel.
1200 by 2 or by 4?
1200 by 4, well, total, right? So
okay.
split that up.
Okay.
Actual rating is according to them, 215 by 4 at 4 and 784 watts bridged, which we'll check that later.
Okay, so they're doing more than rated power right now.
Yeah. Yep.
With 2 channels driven.
Yep. Yeah. According to the amp dyno, yes, they're doing more than rated power.
Okay.
All right. So back to this. We're going to go back through and choose 4 ohm again. I'm going to turn on this other amplifier. Loads are on.
Now this is a
signals
second
on.
amplifier?
This is a Kicker Powersports amplifier.
Okay.
I don't know if you can see it in the wide cut. It's a pretty small package. They'll be soon.
Okay, so this is the Kicker amp. And what's the
Yep.
Kicker amplifier rated for?
This is rated at 404, so it's 100 watts by 4 at 4 ohms.
Okay.
Is what we're rating it at. As people probably have noticed, our new amplifiers are all rated at their higher impedance on the multi-channels. So 4 ohm power is 100 watts by 4 is what we say.
Okay, okay. So we're just giving the consumer a little easier way to understand what they're buying.
Yes, sir.
Okay. All right, so you're running the test. Now you're running just 2 channels, or you're running all 4 channels on the Kicker amp?
This will be 2 channels. We'll do 4 channels later. But yeah,
Okay.
that's
Okay.
the other thing I have to swap. And this is the oddity tonight. We don't normally have the amp dyno in this room. So
It's okay, Joe.
kind of jumping back and forth
You're
here
doing fine, Joe.
as we go through this.
Colin with a K should have been in there helping you tonight, but
Yeah, you know him. He's not going to come in on this
talking to
show.
you, Colin. I had lunch with him today, and he said, yeah, no, Aaron, no thank you, not interested again.
So there you got 125 and 126 watts.
Okay, and that's 2 channels driven into 4 ohms.
2 channels driven into 4 ohms.
Okay, you got that written down back there? Okay, they got it written down.
All right, so now we're going to switch over to the audio precision, right? So we have our basic numbers of what the amp dyno says these things will make.
Okay.
We'll come back to that later, possibly.
So now these 2 amplifiers, if you were driving identical speakers with these 2 amplifiers, you would hear virtually no difference between the 2 because the power is indistinguishable to the human ear. Is that about right?
100 watts, yeah, you'd hear that, but it would be not substantially louder, right? It would be kind of louder.
Okay. So about 3 dB.
Usually takes twice the power to kind of get a really good difference between one and the other, but I would believe 1.5 is normally what you can kind of tell.
Dude, is that the new pizza box amp I read about?
That is the new pizza box amp that you've read
that's
about.
Fantastic.
All right, so should be on again. Yep. AP sense leads are orange and red, which I'm set up for. All right. We need to switch the camera. Yep.
Switch camera.
Yep.
Oh, sorry, we didn't send JW to the lab.
It's all right. We're a shorter person.
Tim had a birthday and he stayed home. Smart man.
Well, and we had Knowledge Fest last week, so he's worn out, right?
Yeah, he is. That team is tired. JW was in Maryland last week, and he managed to make it in tonight. So thanks, JW. It's your birthday and you're due some comp time, so here you are.
You're working extra. We appreciate that. All right, you got that? Thank you, sir.
Okay, let's take a look at what he's doing. So Joe, walk us through it again real quick, what you're doing.
Okay, this will be a power bandwidth test. Well, no, this is actually a power versus THD test, sorry. Want to make sure everything works. Yep, everything's working. Okay. So what we have here is basically a reference panel. We're referencing it at 4 ohms, 1K, and then we're going to send from 100 millivolts up to 2 volts into the amplifier, which has been preset because that's what this amplifier needs to get to max power. And we'll put a scale to it basically.
Okay.
So we're going to go ahead and go.
So this is the pizza box amp.
We'll go to page 2 here.
Okay, now what's plotting here right now? What are we looking at?
So here you're looking at power versus THD.
So what's the divisions at the bottom? That's wattage on the bottom?
So this is watts as we head out here.
And up the left hand, what's that? Oh, sorry. Stop talking.
We got something going on. What is going on here? We got
That's because we're live, Joe.
It's because we're live, yeah. So we've got signal, we've got both clip leads, which are all good. Why are we having this thing freak out all of a sudden?
Bill, we got any questions that I can answer while Joe is reworking that setup?
There we go. That might be better.
No questions?
Let's try
yet?
this real quick.
Looks like Andy's going to take the pizza box name and run with it.
All right, we should be able to go now. All right, we're going to redo this sweep.
Okay, let's start over. All right, so it looks like it starts at about 10 watts. Oh,
Yeah, so
okay.
with the sensitivity right now, it starts in about 10 watts.
And then it falls hard at right at just above 200 watts.
Yeah, it's clipping on itself, which is new and different. Lovely.
Yeah, because you tested this
Yeah,
yesterday. And it worked fine.
I tested this earlier actually, a couple times. What is going on? Why is that clipping out? That's why it's clipping out, because I missed a step.
Oh, okay. It's all right. The pressure's on. Pressure's on.
I even wrote notes to myself for this. All right, let's try this again.
There's no
500
judgment.
milliwatts to 4 watts. That should be good. Go. All right, there we go. That's more what it should look like.
Okay. So it starts down a little less than 1 watt, and then as it increases in power, it looks like the THD is going down.
THD will go down for a while, and then when you get close to full power output, THD will climb, right? So, and these are actually as far as output FETs are, so we'll talk about this a little bit, right?
Okay.
So you notice, okay, let me turn off the outputs so the amplifier continues to be happy with us. All right, back to page 2. So what we see here, right? So you have, start out no power, right? This amp you'll see later on kind of has a high noise floor, so we're close to 1%, even at 1 watt down here. But as we come down, right, gets lower, gets lower, gets lower. This right here is very typical in a lot of amplifiers. This is where the FETs switch over and change into high current mode, and so you'll normally see a hump here. In some amplifiers you'll see a real big hump, but this isn't too bad. Overall, fairly smooth to graph. What we'd like to see maybe is it to be a little lower in some cases, but overall good power graph, looks good. And at 1, so this is all done at 1K, right?
1 kilohertz, okay.
Yeah, so at 1 kilohertz, 1%, real power is actually 254.
So it makes 254 watts at 1% distortion.
At 1 channel driven per time. Right?
1 channel, okay.
And so this is your pretty easy because you're not loading the power supply down.
Okay.
But even with this, what did the amp dyno say we made?
Amp dyno number, Ernie, was that the pizza box? Yeah, the first one? 284. So
Okay.
284, 261.
So if we look at that, right? So 261 is about 2% THD, and 284 is probably close to 4 or 5% THD. And this is why I say the amp dyno is a good, like, seat of the butt, good idea what the amplifier makes. It's not exact every time. So if you run the amp dyno over and over and over, you'll get a different response every time. If you run an AP over and over and over, as long as the amplifier doesn't get hot and lose power, you'll get the same response every time. And so, yeah, this is a much more accurate representation. And what you're really worried about on a 4-channel amp is this range here between like 10 watts and say 70 watts.
Okay.
With full range music, because the music's recorded logarithmically, you don't really have that much energy in the high end. And so with a full range amp, you're averaging in daily listening, even at moderately high volumes, is between 10 and 20 watts.
Okay.
You don't get into this range until you're like out there just screaming, because music's dynamic. You'll have some stuff that's into clipping, some stuff's not.
Sure.
But overall average energy, you're normally in this 20 to 50, 60 watt range. And so this is where it's really important, right? And in this case, it's all below 1%, not bad. Not a bad output overall.
Okay.
Pretty good actual output design as far as like the switching of the Class D, right? So that's THD versus power. Our next test will be CMRR, the test that keeps the noise out of your system.
Are you going to test the kicker amplifier?
Yeah. We'll do them. We'll do one and then we'll do the other.
Okay. All right. Sorry to jump ahead.
It's too hard to switch back and forth and keep anything fluid here.
Gotcha.
So with CMRR, what we normally do is all the way from 20 hertz to 20 kilohertz. But what really matters is like that 1 kilohertz range to 10 kilohertz, because that's where your noise normally is.
Okay.
So we're going to go ahead and run this one. And so we have at 1 kilohertz, 20 dB, 22 dB, and at 10 kilohertz, 9 dB of noise rejection. So what's that mean?
Yeah.
It means the inputs at 10 kilohertz will reject 9 dB of noise and 20 dB at 1K, right? So a little bit of rejection, not bad. Yep, better than having 0, which I have seen amplifiers that have 0. So next one, signal to noise, right? This is one of the more important ones, especially if you like to have your windows rolled up and listen to something and like to have it loud and don't want to have the hiss in the background. This is the #1 test that probably matters.
Okay.
And so in this case, basically, you're just taking a signal, you're sending 0 signal in, and the AP is going to measure the noise on the lines and give you your signal to noise number. So here we go.
So what the AP is going to show us is the noise that the amplifier itself is creating.
Yep. And so at this point, right, so down here you can see, and you can run this over and over, right? On average, 61 and some change of signal to noise, right? So kind of a noisy amplifier is.
So let's back up. So that's 61 decibels of noise is coming from the amplifier with no music present.
That's your noise floor, basically. That is
Wow.
the noise floor of the amp. And if you can, I don't know if you guys can see down below, if you can see the yellow on the oscilloscope here.
No, we can't.
It's too low. Let me see if I can move this up real quick. It's fairly portable. Can you guys see that now?
Yes.
So you see the yellow on the oscilloscope?
I'll go a little higher with it
Well,
if you can. Yeah, okay, we got it.
yeah.
We got it.
So you see the yellow here?
Yes.
That is actually the noise that the AP is measuring on the amplifier. So we have a filter in place, a 20 kilohertz filter, brick wall filter, audio precision aux 25 for Class D switching. So it rejects all the high frequency noise that's out of the audio band, but this is the noise that's in the audio band.
So if you're listening to this amplifier play some music at a moderate volume, you might actually hear the amplifier over the music.
Depends on where you have the gain set. If you have the gains cranked wide open and then have the music barely playing, yes, you're definitely going to hear this.
Okay.
And that is the problem with signal to noise. As you crank the gain up, it's going to get worse. So as an idea here, just to show, we always test in the preferred mode, which is gain all the way down, because that way everything's the same. But if you go over here and turn the gain up some and rerun this test,
Okay.
you see you just lost 3 dB. And so the farther the gain goes, the more you lose, 45 dB.
So for the guys and girls that are just setting the gains half out of the box just because, they're probably getting a lot more noise than they should.
Yeah, because your real goal is to have enough voltage in front of the amplifier to basically leave the gain off.
Signal voltage.
Yeah,
not,
signal
power
voltage. Yeah, signal
okay.
voltage. So if your amplifier can take, like our amplifiers are 125 millivolts at max gain and 5 at min. So for ours on RCAs, if you can feed 5 volts into them, leave it all the way down and you'll get the biggest signal to noise, the highest crest factor for dynamics that you will, right? Okay. So I mean with this one, the gain all the way up, you're down to 40. So you lost 20 some dB in noise rejection by turning the gain up.
Yeah.
And that's something that's never really talked about in gain setting, but the goal of gain setting is to get the highest signal to noise number as you can and match the signals. And so lower gain, better sound.
So that's one reason that in our trainings we talk about using the amplified output of a radio versus the RCA output, because in most cases you're getting a higher quality, higher voltage signal from that amplified output versus the low-level RCA output. Is that correct?
In a lot of cases, yeah. Unfortunately, the days of the 90s radios where they have, every radio has its own isolated RCA outputs that are before the amplifier IC is kind of gone. There's some radios out there still like that, the PR80S from Pioneer. A couple Sony ES's,
yeah.
But there's a lot of the radios that people are buying for like $199 and down. They're basically deriving all the signal outputs for the full ranges off the amplifier IC.
Okay.
So they basically grab the amplifier IC, take it to a voltage divider, put a cap in line to strip the DC off. It's like its own little LOC built into the head unit, right?
Sure.
And then you get your RCA outs. Well, that's just defeating the purpose. With speaker level out, especially if you're not driving a speaker at 4 ohms, so you're not drawing a bunch of current from the amplifier kind of becomes a preamp. So most amplifiers, especially ours, have like a 10K input impedance. So what that means is when you hook up a head unit to it, it's still going to make 10 volts, right, if it's a 10 volt head unit. But instead of drawing 5 amps and passing 4 amps of current through the chip amp, it's going to draw like 100 millivolt, 100 milliamps, almost nothing. And so your signal to noise goes up, your distortion goes down, and you get a cleaner signal because you're farther away from the noise floor than you are if you have a 1 volt or a 2 volt output.
Joe, you'd be a great trainer. We're going to take you on the road.
Hey, anytime.
Okay, what do you got for us next?
Okay, so that is CMRR on this amplifier, right? Or SNR, sorry. We did CMRR. The next one, and this is the last test that we're going to do right now on this amp, is called power bandwidth. This test is normally done 2 ways. One is done at 1 watt. So you basically set the amplifier up to make 1 watt of power. You run the signal to it. You look at the frequency response. Life is good. The second test is at full power. And when you do it at full power, according to CEA 2006, it's supposed to take 60 seconds, and whatever the lowest number is over that frequency response that you claim is the number you choose. This is a newer standard. It was kind of in the last one, but it wasn't defined really well. In the new standard, it's defined much better. And this is where you can find some things with the amplifier that maybe weren't as you thought they were.
Okay.
Because when you start pulling power through inductors and coils and caps, you start to shrink your frequency response in some cases, or you can find where the filters weren't made out of high enough values to pass that kind of current, right? So the inductor's too small, it saturates, and you lose, your THD will either get affected or your frequency response will get affected. So we're gonna do 2 tests here. Let me make sure I put this back down to 0. Okay, it is, it's on min gain. The first test is gonna be, we're gonna do a 1 watt. We're gonna do a 1 watt test.
And this is the pizza box amplifier.
This is the pizza box amplifier still. We'll do all this with the other one here in a second. So we're gonna set this one up to 1 watt right now. That's probably gonna need to go to like.
So 1 watt on the output and a few millivolts on the input.
All right, so 1 watt, 126 millivolts in. And now we're gonna do a sweep and we're gonna look at page 2. I'm gonna need to reset this. We'll stop this, we'll do it again. I'm gonna need to reset the schedule here because this is gonna be 0 and that's gonna be like 15. All right.
We don't want to let the smoke out yet. That's at the end of the show.
Not yet, no. So
Okay.
here, so you're gonna get 4 lines in the end, 2 to start, right? The bottom line that you're looking at here is frequency response. The top line is THD.
Okay.
So a couple things here that are a little weird, right? You'll normally see some low end roll off on Class D amps down here because people put a subsonic filter on them, so pretty normal. Sure. You get over here though, you're seeing a roll off here even at 1 watt. That's an indication that something is probably not designed correctly, and we'll look at that with full power here in a little bit. But here's an indication of where the signal to noise problem is, right? So at 1 watt of output, your THD is almost at 7% across your power,
Wow.
across your frequency response. And that's an indication of that low SNR, right? So if you
Yes.
had a higher SNR, this would be dropped. So this is the test that everybody, well, that all of us run in the big manufacturers to make sure. And then here's the secondary test that we'll do. And this one, we're gonna regulate to around 1%, which if I remember right, is 225 watts on this. Yeah, about 0.7, all right. And now we're gonna do this same sweep again. So,
Okay.
and this will be at bigger power, which means I need to change that.
Okay, so there's a lot going on here.
There's a lot to see here. Yeah, we'll break this down here in a second. All right, let me turn the outputs on so the amplifier stays with us. All right, so what do you see here, right? So you've got your 2 power line or your 2 THD lines, right? They're right about 1%. Actually, when you get up here, they're below, and then in this range, they're above, and then they drop back under, right? So pretty good. But here, you start to see the roll off on the low end, which we'll talk about in a second. But so your average is like 225, and that's right in here, right? So Right about 1K, you're at 220. So you're actually, where we do our 1K test,
Okay.
a little bit low. So if you did a test at 500 hertz, you'd probably find an extra 5 watts or so
Okay.
of output, because this is the same test but showing THD and frequency, right, instead of just one frequency in THD. So power comes up, power starts to drop actually, and THD starts to rise about the same time power goes down, if you look at this.
Yes.
And that's going to normally be the case, right? So as power starts to drop, THD is going to rise. And what's happening there is that's an inductor or some type of output device starting to saturate.
And saturation is bad.
Is bad, yeah. Basically, the part can no longer control the energy that you're putting into it, so you're overdriving it. Normally, because bigger inductors cost more, right?
Sure.
And so this is what you get. But if you get out here to 5K, and we'll turn this into dB in a second, right? Because right now you can see the power, right? You've got 225 watts of power here in the middle, and then you drop down, you're at 180. By the time you hit 4K, by the time you hit 10K, you're right about 120 watts. And by the time you hit there, you're 80 watts, right? So let's turn this into dB, because this is how this test is done when we're looking at, let's see. Let's see what that
Joe, I'm going
shows
to take a question real quick while you're setting
too
that up
big.
for us. Bill, can you pop up that question for me? So Stu's Custom Shop. Joe, if a customer brings me a 2-channel amp and a pair of single coil 4-ohm subs, would it be better to run them 4-ohm stereo or 8-ohm bridged? That's a great question, Stu.
The power is going to be the same as long as the amplifier can do both. To be honest, you get some advantages of running them in stereo mode that you don't in bridge. That's stereo separation, which there is some music that has that, not
Sure.
a lot, but some. And you're going to work the amplifier a little less, even though the amplifier impedance that it sees is the same. When you bridge something, you draw more current, and so there's a slight loss of efficiency. So probably I would say in stereo mode.
Okay, good. So Stu, keep it in stereo. Thank you, Joe.
Yeah, no problem.
Thank you, Stu. Good question. Okay, what are we looking
All right,
at?
so we converted the power, wattage into dB, right? Because as we call it, 3 dB down is the frequency response, right? So if you go over here, here we're up, 4, 5, 6, basically 7 dB, right? So 3 dB down where you cross the 4 mark, so that'd be right there. So technically, at full power, the frequency of the response of this amplifier stops at 28 hertz.
Okay.
So it shouldn't be 20 to 20K, which is what it's rated, right? That's actually 28 hertz. And then down here, from 7 to 4, right at full power, it's done at 4K.
4K, 4,000 hertz.
Yep.
Full power, okay.
And so, but because most frequency responses are done at 1 watt, this would have passed that test.
Okay.
But when you actually pull power out of it, this is what you get.
So when you're playing this system loud, it's rolling off the high frequency.
It's rolling off the high frequency. So this amplifier probably sounds a little dull.
A little what?
Dull. Yeah, not like, you're kind of losing that high end. So
The
when
sparkle, yeah.
Yeah, it doesn't have much sparkle to it when you're playing it, and you'll probably find yourself EQing or DSPing up the top end to fix that problem, right?
So if you've got some bullet tweeters, you're good to go.
Yeah, those would probably work just fine.
Okay.
And so that is the end of this amplifier. Give me a second to switch over to the other real quick.
Okay, well that was great. So audience, are we learning stuff from Joe again tonight? Please put some answers in there. What kind of stuff are you learning that's useful when you're designing a system, maybe for yourself or maybe a buddy? What are you learning? And we're walking. We're walking. Martin, were you here a couple weeks ago?
We're walking.
Okay, so for the audience, so apparently Martin was here at our Kicker University a couple weeks ago. So you look at the back of my shirt here, Kicker University. So a couple weeks ago, we brought in a bunch of our retail partners from around the country, and we gave them a full facility tour. And so I have these flags that I can hold up in the air because this is a huge facility. With 40 people behind me, you can't really see where I am. So I hold this flag up and I say, and we're walking, so they could all find me. So thank you, Martin, for bringing that up. That was fantastic. Oh, Pete, yeah, Pete. Pete was here as well. Pete Daly, he's one of our independent reps out in Texas.
We don't know Pete.
Andy, learning a ton. Can't wait to talk about this on the after show. Thank you, Andy. Great to see you again, buddy. Steve's Custom Shop, we're learning pizza box. The pizza box line probably ain't gonna be what you want to go with. Yes. You know, we should probably trademark pizza box amp line before someone else does.
Other camera? No. my computer's in between.
All right. All right, Joe, enough of me talking. What do you got for us?
Okay, so we're going to do the same test, hopefully in the same order if I remember that, on our powersports amp here. So as we did before, right, this amp was, what, I think 125 watts on the AP. If I remember right, is what it said.
On
so
the
on the amp dyno.
Yeah,
sorry.
dyno, about 125. Yep.
And that's why I check.
Oh, Pete says we need eye protection. Not for you, Joe, but for me with the flags. Eye protection. Thanks, Pete. That's helpful. Let me write that down.
Were you waving around too much?
Apparently, Pete thinks so.
All right.
Okay, so this is our 4-channel powersports amp. You're doing 2 channels to run it, to run the AP test.
And we should be good to go. Yep. All right. So same thing, power sweep at 1K.
Okay, can we switch cameras so we can see what Joe's looking at? He's a handsome man and all, but we're here to see the graphs, not Joe.
I'm pretty sure everybody's here to see me.
Maybe Megan is. So the yellow line is the 2nd channel going
Yep.
through it? Okay.
Yep.
All right, so talk to us. What are we looking at?
So in this case, let me blow this up. It's easier to see. So power, right, you'll notice, if you remember right, the other amplifier started out close to 1%, came down to 0.5, was in 0.543 right here, and then came back up. So you'll notice, you can probably assume that our noise floor is going to be lower, right? When we get to the SNR test, you should expect it to be better because you're seeing less THD here, right? So in our amplifier, right at 1%. On our amplifier, you're 123, 124, right where it crosses. So amp dyno was pretty close on this one.
Okay, very nice.
And I believe, I haven't been able to prove this yet, I believe the higher the noise floor of the amplifier, the harder the amp dyno has the time of finding the power number. At least from the tests that I've done, that seems to be the case.
Say that again, please.
The higher the noise floor, so the lower the SNR,
Okay.
the more difficulty the amp dyno has of getting a 1% number, right? It seems to always be a little high.
Okay.
Like it adds some of the noise floor in or something.
Okay.
But like I said, it's still close. It gives you a number. You're able to do A to A tests with it, and so you're able to get a good idea of one amp versus the other at one frequency, right? So it's a good tool for what it is. Here, you can see we stay below 0.2% THD all the way up to where we get our little bump. Remember how I said most amplifiers have a bump?
Yes.
You can see here we have the little bump. You'll notice ours kind of more of heading up instead of being flat and bumping. We've got ours dialed in a little better to where it's almost right at the corner. On a perfect amplifier, you'd literally see this come across and pretty much just brick wall and turn up.
Okay.
And we do have some amps like that, but that's your design has your layout. That usually comes down to your layout and your component selection. It has to be perfect.
So we're talking about a power sports amplifier, and power sports amplifiers, of course, are not designed to be listened to in cars with high fidelity music. These are designed for motorcycles, quads, ATVs, UTVs, where you're just pushing SPL so you can hear it over the roar of the engine and all that kind of stuff. So this amplifier sounds fantastic, even in that application.
Yeah, it's actually the amp I use in my competition truck. Yeah, for my
Okay.
4A. Just had it for about 9 months now, thanks to
Okay.
COVID. So yeah,
We're gonna take a question real quick too, Joe.
Okay.
I got to interrupt you again. So let's look at our first question. We've got Christian D. Shadow. Which kicker model are you testing? Specs are important to pay attention to, and what's advertised, but may not give the output performance. So
yes.
go ahead. What are we looking at?
This is an amplifier that will be launched in the first quarter of next year. It's the replacement of our PXA line. So I don't know if you know our old PX line, but we had like a 304, 501, 201, pretty small line.
Right here, actually.
Yeah, and so we've expanded that line, added more power, added more features. This line was supposed to be out in 21, but of course COVID came and parts problems came, and so it's been paused, but it's actually going in production right now, and so it'll be out for probably Q1, Q2 next year, and you guys will be able to buy it.
Thanks, Christian. SJC Audio Guy, Kicker team, would limiter or noise gates assist with total harmonic distortion? Noise gates or limiters?
Only at mute. So I don't know if you've ever had like the old Xtan amps, the nice chrome pretty ones that looked beautiful.
Yeah.
Were a pain in the butt to work on, and you had to take them off and like jumpers around and put modules in. They had a noise gate in them. And back then, because everything was single-ended RCA input, it was very helpful of getting rid of noise at low level, right? So you had like that low level engine wind when you had the music turned all the way down.
Yeah.
So you could literally set their noise gate at like 1 watt, 2 watt, 3 watts. And as I said before, most of the time when you're listening to music at low volumes, you're below the 10 watt mark, right? You're not making that much power on full range speakers. Now on subs, it's a different story. You could actually set the noise gate high enough that basically it would just mute the amplifier once it got so low, and so you didn't hear the whine. And then when you got above that, it would unmute, right? That's kind of how noise gates work. They won't help with THD with music playing, but they do help when you get under a certain level and basically mute. Limiters are different. Limiters work by clipping or compressing, in most cases, the signal. And so all that's going to do is actually make your noise worse if you use a limiter, if you're hitting the limiter, because the limiter, the noise is going to be of a lower input voltage than your signal, and your signal is going to get clipped, but your noise is going to continue to grow as you turn the gain up. So
now, Joe, we use some limiter technology in our Key 204.
we do.
How's that implemented so that it's not a problem?
So we call it a limiter, but what we do is we actually take and measure the input voltage versus our output voltage, actually power, right? And when we get to about 1.5%, 2% THD if you have the switch down, and I think it's 5% THD if the switch is up, we basically stop taking any more input voltage. So we basically turn down the DSP gain equal to how you're turning up the input gain, right? And so we basically stop you from overdriving the outputs, which is why with that amplifier you can basically keep turning the knob on the radio and it doesn't get distorted or louder, and it just stays playing clean, right?
Yeah. Good, thank you, good question. Let's take one more question and then we'll get back into the testing. Larry asks, what was that amp rated at that is going to blow up tonight?
I don't know if it'll blow up or not. Its little brothers did. We'll see if it will. The ratings on that amplifier, they say it's 215 by 4 and 784 watts by 2 bridged.
Okay, so they made more than rated power so far.
But we were only running 2 channels. So there's no power supply sag. So yeah, we'll see how it goes. I don't know. But I want to do that last because I'd like to get through the rest of this.
Okay, yeah. Continue, Joe.
Okay.
Sorry.
So here's our power versus THD, right? Good THD, good power, nice curve.
Switch the camera, please.
And so now we're going to do CMRR. I think that's what we did next. And so once again, if you remember right, this is the ability of the amplifier to reject noise. If you remember, the last one started out at 20 dB and went down to 9, 22 dB and went down to 9. This one is pretty much 54 to 51 all the way across. So across the frequencies that matter here, you're going to have over 50 dB of noise rejection on your RCAs. So as we know, 3 dB, you can tell 6 dB is twice as loud. If you cut something 54 dB that's radiated noise, it's basically muting it. If you look at our bass knobs that we use, they have like 34 to 38 dB a cut. And if you have your radio all the way up and you turn our bass knob all the way down, even on a 2,000 watt amp, what do you get?
Yeah, you can't hear no sound.
Nothing, yeah. Basically it's mute, right?
Yeah.
So with 54 dB of noise rejection, this is part of the fit circuitry that we use. Basically we use differential in, then to an instrumentation amp and some precision components, and then back into a single-ended output to go into the amplifier. By doing this, it costs more because we have 3 or 4 stages on our input stage that you technically wouldn't need. But we believe it's worth it because it keeps you in the install bay, or you as the consumer, from having problems from any of these cars, right? You know, you got aluminum trucks now, you have a bunch of bodies that are glued together and don't have a really good ground, all the digital noise that you can have in a car. So we're trying to do a good job of making sure that when you put something in, it's as least problematic as possible, because you already have enough to deal with in the integration world at this point.
Awesome. Thank you, Joe. That's great.
Right. So there's our CMRR score. And we'll do SNR next. All right, set up, hit go. So if you look at our SNR, about 80, 81 dB. So I think if the other one was 60, 61, 62, if I remember.
That's about right.
So we got 20 dB more of signal to noise rejection, or the noise floor is pushed down 20 more dB.
So even at low volumes, you're not going to hear the amplifier
You're not going to have
its own noise.
Yeah, if you have hiss with these amplifiers, you've done a poor job of setting up the gain.
Which we get that call a lot.
Right, I have hiss. Well, how did you set your gain up, right? Because on these amplifiers, pretty much everything we make is 75 dB or greater. On general, right? So you can go to our CX amps, pick one. They're all pretty much 75 or up. We do have some sub amps that I think we rate at 70, but if you actually test them, are like 74, 73 and a half, 74 and a half. And because we always want to meet or exceed our standards, because they don't quite hit 75, and actually in our cases hit 77, 78, we won't call them 75, and we don't do any in-between numbers, so we always go. So we call them worse than they are, right? So we'll call them 70 when they're really 72, 73.
Under promise, over deliver.
Yeah, and we try to stay above that 70 mark, because when you get below that, even with a subwoofer amplifier, you can start hear that kind of rumble at low frequencies that's noise, and we just don't want to have that with any of our stuff, right?
You mean that useless information?
Yeah. Now power bandwidth, right? So we'll do a 1 watt again.
And
Like
2 channels driven.
2 channels driven.
Okay.
We're going to do a 1 watt again. And I might have to make the 0.05. Turn the outputs on, regulate. All right, so we'll go ahead and do a sweep, but I'm going to need to change that to 0 and that to like, all right, go.
And the bottom line is what?
That's your frequency response,
Okay, and the top line,
your THD.
total harmonic distortion.
Yep.
So the frequency response is ruler flat,
Pretty much ruler flat, yeah.
and then the distortion is how many dB above that?
The distortion's this side, right? So it's 0.01% at 1 watt.
Okay, so it's
So
tiny.
you remember how they were up at 10% THD across the top here?
Yeah.
Yeah, so and this is the exact reference of what SNR gives you. So by your SNR being lower, your THD at lower powers is much lower. So to do something in between here, we didn't do this last time, but let's do 10 watts, because like I said before, this is where you're normally kind of actually listening to your music. So let's run this again. Yeah.
So 10 watts instead of 1 watt.
Mm-hmm. So frequency response for the top two. And THD is the bottom. So you'll notice THD is still really low, 0.01, humps up at 0.02 right at 6K. Frequency response is pretty much ruler flat, yeah, because this is down 8 watts. If we change that to dB, which is what we want to look at, so if we go here, and go dB, I'm going to adjust that. You're down maybe 1 dB.
So an inaudible down at 20 hertz or 20K, which anyone over the age of 15 can't hear 20K anyway.
But yeah, and so with Class D amplifiers, like I said, you normally have a subsonic filter. If we switch this out to like 10 hertz, you'll start to see this roll off on the bottom end, because I think we have a 15 hertz subsonic. Now the other thing is people are talking about a lot right now is high-res audio, right? What is high-res audio? Is it better? Blah, 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 blah. Take your choices. Well, there's two specifications for high-res audio that really matter. One is how the file is encoded. Now, you can argue that is better or not. I'm not going to get into that tonight because that's a long story. But let's talk about their audio requirements, right? So the requirements for speakers or electronics. So to be a high-res head unit or a high-res amplifier, you have to play out to 40K at negative 30 dB. Well, as we talked about before, 34 dB is pretty much mute unless you're a 1,000,000-watt system. So, right, how does that work? Does that work? Well, let's see if this could be a high-res amp. I haven't actually done this test yet.
Ooh.
But let's see.
Unscripted, untested.
Unscripted. I've been curious about this some. So 40 kilohertz.
This is live, Joe, remember.
And we're going to go down to 10 hertz. Let's see what happens here. All right. Let's regulate one more time just to make sure it's right. All right, let's go.
Okay, so tell us again what you're doing.
We're going from 10 hertz to 40 kilohertz.
10
or
hertz?
maybe 400 kilohertz. So
Okay.
we'll see where the frequency response drops off on this thing. And so, yeah, so there you go. So there is a brick wall. Oh, we have a brick wall filter in place. That's not our fault, that's their fault. Hold on.
You mean the AP has a brick wall in?
Yeah, the AP's got a brick wall in it because we're filtering out Class D noise.
That's right. You told us that in the beginning.
Yep. So let me remove that real quick, and let's see what it really does.
So we take another question. Let's take a question while Joe is reconfiguring. So next question, 25 hertz to life. Has Kicker experimented with a double stack amp board? Does it have any benefits? Double stack amp board, Joe, any benefits to that?
So are you talking like something like the Incriminator 8K or whatever, where it's basically two amplifiers stacked together, flipped upside down, put in a housing?
I can't tell based on his question, but he just says a double stack amp board. Maybe two boards. I mean, we do that anyway, right?
So what we do, we have 2-layer boards, 4-layer boards, 8-layer boards in our designs, depending on how complicated they are. There are some kind of off-the-shelf designs out there that have reached for more power. And in doing that, they've basically like clamped 2 half-bridge amplifiers in a chassis. So either back to back or one over the top of the other, and one's and then kind of hooked all the connections together. That's actually counterproductive, but it's a lot cheaper engineering-wise than engineering a new amplifier. Typically, what we're headed towards, and what we're doing more and more of, because most of the stuff's Class D, is we're starting to put like the Class D driver boards on their own headers or vertical. And that way, when they come in for manufacturing, you slap in the boards on the top and you do the main PCB. It's quicker, and then if you ever need to repair them, replacing driver boards, because IRS 2952s and 2997s and that stuff quite often can be a failure mode. So it's easy, you pull one board out, put another one in, right? It's a very quick repair. You don't have to disassemble the whole amp if that's the problem. Now, if it's FETs, well then, of course, that's the other thing that fails on amplifiers. You're gonna have to tear the amp apart to get to the FETs.
Okay. So not really a huge benefit to doing that.
Not that not the way that I've seen it done, no.
25 hertz also asks, are we gonna test an AB amplifier? I don't think tonight we are, right?
Not tonight, no, but we can definitely, if you guys like these more technical shows periodically, we can set something up to where we take some requests and we can try not to blow stuff up or try to blow stuff up and test whatever we want anytime. Like we've said, we're not gonna show other people's amps for a test, but I have no problem testing others, testing ours, taking requests, trying to figure things out for people if they want something that's very technical. We can definitely do that.
All right, Joe, let's go back to your testing.
Okay, so let's see what happens with the brick wall filters out of place. But that needs to be 40 kilohertz because the AP doesn't go out that far. All right.
So 10 hertz to 40,000 hertz.
Mm-hmm. And could not be a high, well, actually. Need to change this scale.
So it looks like it's dropping off right about 20K.
So, which is possible. These have a DSP in them, so that's completely possible. Yeah, so we're down 4 dB at 22K, and we drop pretty hard. So we probably get to 30K at the negative 30 point. but not 40K. So you couldn't really call this a high res because of where we're dropping off with the DSP.
Well, and high res in a side-by-side is pretty much useless anyway.
Yeah, no. So just a fun test, something doing different.
Well, thanks for doing that, Joe.
Something I wasn't planning on doing. Let's see, let's get back to normal here. Now we're gonna do full power, which on these was like 120 watts.
You got to put your brick filter back in?
Yeah, I probably should.
Just so we don't.
Just in case we don't get it that way, our noise readings are correct.
In the comments section, people are calling out amplifiers they want us to test. I have a feeling we're going to start receiving amplifiers unsolicited for testing on air. We might have a whole new segment for you, Joe.
Does it blow up? Okay, so here we go. So this is the full power test. I'll put this back into power when we're done here, but right now it's in dB.
That's pretty straight.
Yeah, so let's put this back into power.
So in this AP, you're using just a few of the possibilities, but it looks like it can do a whole lot more stuff than we're using tonight.
Yeah, I'll show you all the other tests that we have pre-made, and that's still not only probably half of it. So here, power's the bottom ones. Let's see here. Green and yellow. Or cyan and yellow. Yeah, power's the bottom ones. So you'll see we are down 10 watts maybe at 20K. THD stays pretty flat. We're actually a little high here because we're up in 2%. So I really should probably regulate this to like 110 as the amplifier is probably hot now that we did all the extra tests.
Oh yeah, you're pushing it hard.
It's still hot. Yeah.
That's a good point too, is that testing amplifiers at different temperatures.
Yeah, you pretty much want to let them cool down in between and then test them again.
So this is the same test again?
Same test, a little lower output power, just try to get under 1% THD for the average number.
Okay.
Because we're real close to clipping now that it's gotten hot. And you'll see this little rise here at the end and a little fall. So if you remember on the other amp, it fell way down here at 5K, right?
Yes, yes.
This is really typical of what you see as Class D full range amplifiers. Is you'll literally lose 5 or 10 watts at the top and your THD will start to rise. And that's because if you've chosen appropriately sized output inductors and components for the Class D filter, that is how it's supposed to work.
Okay.
And so if you look at a lot of actual AP testing on Class D amps, from any of the big brands, you'll see a lot of them that kind of do that. Or if you let it go out to 30K or farther, you'll see them start to do that. They all do that somewhere in there depending on the size of the filters.
I've seen that on an RTA in several cars, and that's an interesting explanation. So even your tweeters are completely on axis in a custom build, you could still be rolling off the top end because the Class D is doing that for you.
It's just a little bit, yeah. I mean, in this amplifier, just barely, but in others more so, right? Depends on what you have. So right here, we're at like, we're going to call the rest of it 100 watts, you're at like 93, 94.
Okay.
And so a little bit of roll off.
Good power.
Good power. Everything's set up. Now, if we have time, I'll take a few minutes and bridge both of these amplifiers, and we'll run this same power bandwidth test and see what happens.
Let's do it, because this is where the smoke might come out. Is that right?
It might, yes.
Okay, so we're going to take a question while you're reconfiguring your setup.
Okay.
So Christian is asking, do your marine amps perform the same as these? Sorry, I had Ernie in my ear. Do your marine amps perform the same as these tests? Yes. Yes, they do. In fact, go ahead, Joe. I thought you were muted, so go ahead.
Yes, just like this or better in some cases. If you're doing the KXMAs, they've actually got, in a lot of cases, a little bit better signal to noise and CMRR than this does.
Okay, so
not by much, but a little bit. Right? Every little bit counts.
And again, the marine environment, similar to power sports, It's not a quiet listening environment, so we're still building premium sound quality amplifiers even for that application.
Yeah, completely. I mean, we look at the application that they're going to go into because it's important, but to us, it doesn't really matter as far as the performance level. We have our own internal standards in R&D, and they have to hit it or we don't build it.
El Fuego's asking, if I mount my amp in a pizza box, will the performance be affected?
If you run a lot of power tests, yes, it will.
Yes, El Fuego, you might have El Fuego with your pizza box.
If you do short-term tests, you'll be okay. If you do long-term tests, I would not suggest it. Oh, and this amp has a fan, so we're letting the fan breathe at least.
The kicker amp or the?
No, the competitor amp.
Okay, so the pizza box amp has a fan.
Yeah. So the kicker amp, I will let out of the box that it's IPX7 rated.
IPX7. So IPX7 means that it can take a bath and hold its breath for a while?
For 3 minutes at 3 meters, yes.
Okay. And if you're down there for more than 3 minutes at 3 meters, you got bigger problems.
You got some serious problems with your boat at that point. Yes.
Okay, Larry's asking a question. Is there a larger footprint advantage other than heat dissipation? So are bigger amplifiers better other than heat dissipation?
You can sometimes, it's easier, I won't say it's better, but I can say it's easier to get good signal to noise out of a bigger amplifier because you have more room to run traces and lay out parts.
Okay.
So that can definitely be helpful, right? But as far as overall, do you get more power? Do you get that? Not really. And nowadays, with most of our new amplifiers, we're pretty much all where we do thermal rollback on everything.
Okay.
So pretty much everything nowadays rolls back, adjusts its power, tries never to shut off because we don't want to shut off for a consumer. No matter what they're doing, we want to make sure they keep playing. And so with the capabilities of the new amplifiers with thermal rollback and all the goodies that we have in them, you just really don't have a whole lot of advantage from a bigger amp except for maybe easier layout and that type of thing.
Lazy engineers perhaps need a bigger footprint.
Well, it definitely.
Just kidding.
No, it's not. It takes a lot of time to learn how to stuff something together and not get noise. So there's definitely an ease of use to it, right?
I saw Fernando at a coffee shop a couple weeks ago. He was working on one of the newer designs that we can't talk about, and he was showing me how he's having to squish, like you said, Joe, he's having to squish things into place. And if some parts get too close to other parts, you start getting that noise problem, that higher signal to noise or lower signal to noise. And so he was talking about some of the challenges he's having with that. And of course, he loves the challenge. So, he's complaining about nothing because he loves it. But it's interesting because you just brought that up with, you challenge the engineers, make it as small as possible, as good as possible, and then we got to make it at a great price point too.
Yeah, and on that particular amp he's working on, if it's the one I'm thinking of, he's already had to throw it all away and start over because he got to the end and didn't like the results. And before he even built it, right, like you had asked before, can you look at something?
Yeah.
He looked at it and he was like, I'm not going to like how this performs, so I need to start over. And so he did, right?
That's tenacity. That's amazing.
Yeah, so it was, it's frustrating when you have to do that because you put all this time, you probably put 2 or 3 months into laying it out, doing all this, and you get to the end and you're like, well,
that's not going to work.
That's not going to work.
Yeah.
Let's start over, right? So.
All right, you ready for us, Joe?
I've got one amp done. Give me just a second. Let me get this other amp done.
Okay. So while Joe is doing that, actually, let me see. I've got a couple more things I can cover here. Joe, how much time do you need?
2 minutes, maybe.
2 minutes, okay. Ernie, I'm going to pull up the pick of the week on my laptop here. So if you could, if I remember correctly, this picture was taken this weekend at one of the events we were covering. Now, that's 2 quad boxes in a F-150. So yeah, Ford F-150 pickup. He's got 2 quad boxes behind the front seats there. And on top, I'm not sure what's on top of the boxes. Brain brain damage. He's got, I don't think that's what it's called, but here, let's, oh yeah, so voice box. Okay, so there's his mids and highs sitting on top of his quad boxes, but holy cow, that's a banging subsystem right there. So that's the picture of the week. So let's go back to Joe. Joe, you ready for us?
I think so.
All right.
All right, we will be testing.
Can we go to Joe in the lab? Get off my laptop. There we are. We got you, Joe.
Okay, so we now have the competitive amp set up in bridge mode. We're going to run a power sweep first, make sure that survives that. And then secondly, if that does, we'll run a power bandwidth test and see what happens.
Okay.
And to do this, though, I need to probably change that to...
So are we watching for smoke now?
I hope not.
Okay. So can we have the camera where the smoke might be? Okay. All right.
All right,
Ernie
so
said if we get
let's see,
smoke,
we have
he'll-
signal, let's make sure, yep, we have power, okay. Here we go, so this is 4-ohm bridged, they rated at 784 watts by 2. Not
784.
sure I believe that, but we'll go to 800 watts here, and let's see what happens.
Okay. So talk to us, Joe. What are we looking at?
So it's power curve, it's getting close, closer. Oh, past 1%, back past 1%. It falls short, but we'll let all 4 of them run here and see what it does.
So in the far right, at what point does that knee happen?
Looks like right before 600 watts.
Okay, so it's not making its rated power with acceptable distortion.
Yeah, and this is the problem when you load all channels, right? And this is the easier test than the power bandwidth test, so we'll let this one happen, and then we'll do the power bandwidth test second. But I'm actually pretty happy. We still have an amplifier, so that's good. So 583 is what it really makes. If you take the first hump, and the first channel had a second hump at 627. So for rated power, it's 150 watts short or so on that number, and 200 watts short on the first knee, where it hits 100.
Okay, so the
hits
pizza box amp is not making rated power when bridged.
Nope, but it does make a lot of power. But you notice THD is still kind of really high, right? Let's take a look at power bandwidth. This is the one I'm worried about.
Okay, get ready with the switcher back there, Ernie. If you see smoke, we want to see smoke. We want to hear caps, smell
That
inductors.
needs to be 800. I'm gonna make that 250. The sweeps are good. That's good.
Joe, I'm shaking with anticipation, man.
So we need to regulate to, what do we say, 650 watts? That's fair.
Yeah, that's about what it was doing.
All right, it's not going to get any closer than that because the 2 channels with the thing are too far away from each other. But okay, so we're close. We will run.
Okay, here we go.
We will try. Nope, doesn't want to run. All right. Let's try 550 watts. See if we can get it to regulate to
Do we
that.
need a block of ice or something?
Nah.
Are the fans whirring away inside the pizza box?
They are whirring away, but it's having a real hard time getting there percentage-wise. So I think I'm gonna have to do this myself. So
You're gonna
do it
force
by hand, yeah. So let's see here. Yeah, it's not liking this at all. THD's through the roof.
So it's not letting you run the test?
Yeah, basically it won't regulate because it's so noisy it can't. So let me do a different test. Instead of regulating it, we'll do time versus power.
Okay, so just to recap, so the amplifier is producing so much of its own noise, the AP can't even run the test.
Yeah, it won't regulate, so I can't regulate it. So,
Oh, Deviant wants a fire extinguisher. Yeah, that's a good question, because Joe's alone in the lab, right, guys? Who's got the fire extinguisher? That pizza box is not flame retardant.
no, it's not. Okay. I'm gonna have to get a number off the first test. What was?
So Joe, while you're doing that, we're gonna throw up some, actually, you know what we'll do? We'll do the first question of the week from
2
Jacob.
volts, okay.
So here's Jacob's first question of the week here. Hi, I'm trying to figure out why my sub keeps smoking and eventually fizzling out. Does having 8-gauge speaker wire hurt it in any kind of way? I have a Hyphonics Brutus 1600 monoblock and one kicker 41 L710, that's a square 10-inch L7 series. I have a second battery in the truck and I'm using 4-gauge wire kit off the battery. So if you're blowing up your subwoofer, there's a really good chance that your signal is being heavily clipped into that subwoofer. That subwoofer can handle quite a bit of power and it can handle some abuse as well. But I suspect if you were to look at the output of your amplifier, it's clipping pretty badly. So one of the easier ways to set the gain on your system properly, first of all, you need to figure out where your source unit clips. Now, if you don't have an oscilloscope, it's a little bit hard to figure that out, but we generally recommend about 3/4 of the volume. You can usually expect the system to be clean. So set your volume at about 3/4, and then you're gonna start turning up the gain on the amplifier. For a sub-amp, you want to use our 50 hertz tone. For full range amplifiers, 1 kilohertz tone. And for subwoofers, you want to use the -10 dB overlap. And for your mids and highs, generally the -5 dB. So for this system, your subwoofer system, again, set your radio at 3/4 volume with the bass and treble at 0 and turn off the loudness. Anything that changes the sound, make it all 0, as flat as you can. And then start turning up that gain. Now you're going to have a multimeter set to voltage AC on the output of the amplifier, the output terminals, and you're going to be turning up that gain until you see your target voltage. So where do you get your target voltage? On kicker.com, you go to the tech section. We've got a whole chart of voltages, 1 ohm, 2 ohm, 4 ohm, 8 ohm. It tells you what voltage you're looking for at whatever system impedance you're working with. When you get to that voltage using the gain, you get to that target voltage, stop. You have just properly set the gain for that system. And if you do that, there's a really good chance you're never going to blow up that subwoofer again. So that's what I would suggest to you. Okay, let's go back to you, Joe. You ready for us?
I'm ready.
Okay, let's go back to Joe.
All right, here we go. I found the regulation number, so we're going to go ahead and run this sweep. We're going to do it logarithmic, and off we go. Let's see how this goes. This is supposed to be a second sweep, but we're going to do a short one here, make sure it survives.
So you're running the test, but you're running it faster?
Yeah, faster. Just want to make sure we can get through it first.
Okay.
Which that did. All right, so life is good there. No kabami. So here we go. We'll go ahead and run the long one.
All right, so now we're
I
gonna
do smell something, but nothing has blown up.
You're smelling pizza. It's just pizza, dude.
So that is so 2 volts. All right. Outputs on and go. And so this is time versus power.
So now the amplifier has to make rated power for an extended period of time.
Yeah, but let me get the scale set up right so you guys can see it.
So this is Men from the Boys.
All right. Go. And so this is going to be power versus time, right? In seconds.
Okay. So, oh, that just fell off.
Yeah, I think it just died.
So the amplifier magic smoke?
It's not in protection. Oh, but I smell it. Yeah, it's definitely not good.
So there's no protection. Turn the camera towards the smoke. We want to.
Well, it's a little smoky in here, but it didn't like let out smoke. But it is definitely dead, I think.
Okay, so tonight, folks, we killed an
it's
amp.
dead. So we killed that amp.
We
All right,
sacrificed the pizza
we
box.
sacrificed an amp to the amp gods. Ooh, yeah, it stinks. Ooh. But it still thinks it's on. Okay, that's not good.
So the amp, maybe you should disconnect the power.
Yeah, maybe I should for that one. It thinks it's on. That's not a good thing.
Oh gosh, that's fun. Joe, you're fun.
Oof, that stinks. Okay.
Am I hearing a fire alarm?
No, but it's definitely smoky in here. Although it didn't let out a big like cap pop or anything, but it is definitely smoky in here.
I thought I heard a high-pitched squeal behind me. Maybe it's just Ernie.
Oof. Okay, that stinks. That'll be fun to look at tomorrow. Okay.
Colin, you got something to do tomorrow.
Oh, no. Give this to one of the engineers. That's why they like me so much.
So, Joe, I'm going to take another question while you're setting up a second test.
Okay.
So my second Jacob Lupke question today is, hi, I have a Kicker 07 CVR 12-inch 4-ohm, dual 4-ohm subwoofer. It sounds clean and deep. I have a ported enclosure that I can put a port plug into to make it sealed. When I play it in a sealed mode at 70 to 80% volume, a crackling noise comes from a spot on the cone and surround. But it doesn't happen in ported mode. Is it normal? If so, what's the solution? Thanks in advance.
Ooh, do I get this one?
No. What? Do you want it, Joe? Yeah, go ahead. What do you think?
Well, there's some very big dynamic differences between a sealed and ported box, especially at tuning frequency, right? So if you're sealing up a box, you're creating a spring on the woofer. So you have your air spring that your woofer pushes against that helps control the woofer. The drawback to that is at low frequencies, you have a chance to bottom the woofer out easier than you do above a tuning frequency of the box. You also have to overcome the box's air, so it takes more energy for the speaker to move. If you're hearing a crackling or a rubbing type of noise that's like clattering, you are probably getting the speaker far enough out of its gap that it's starting to tilt at the edge, which if you have a strobe light, you can actually see that. You'll see the surround start to deform. Now, it's not what you see in all the camera videos where they look like they're doing this.
Yeah.
That's just the camera refresh rate. But if you actually have a strobe light and you strobe a speaker, you can see it start to tilt when you hit the end of its excursion. And when that happens, you'll start to get the voice coil to rub inside. That is most likely what's happening. When you're ported, your box is probably ported at 40 to 35 hertz most likely. So the lower frequencies, the speaker's moving much less and the port is doing a lot of the work. That would be my guess at what's happening.
So that's fantastic, Joe. And Jacob actually filled me in. He said at the end of all of his troubleshooting with this gentleman, what they discovered was there was a small hole where the surround met the cone on the outer edge of the cone.
Screwdriver.
Yeah, that's exactly what it sounds like to me, as a screwdriver. So what Jacob had him do was put a little bit of silicone sealant on it. Problem solved.
So he was hearing the air escape through the woofer when it was sealed because of the pressure. Yeah, that makes sense.
Yeah. Are you ready first, Joe?
I think so. Let me make sure I have enough power here. I should.
So now you're running the Kicker amplifier, same test, bridged, 2 channels.
Okay, yep, I got power. All right, so this will be the same test we did before, where we basically do the sweep. We'll do the sweep first, and then the power bandwidth test second. Let's see, 500 watts, that needs to go up to like 400. That should probably
What's this rated at when bridged?
Bridged rating is 225 watts by 2.
225 by 2, okay. And we don't need the smoke camera for this one, right?
No, you should not, but I do need to reset the graph because it is not right.
25 Hertz to Life says that Joe needs a promotion. What do you think, Joe? Do you need more work, Joe?
Yeah, more work. That's, yeah, could be worse.
You got a pretty good life.
Yeah. So at 1%, About 332 watts a channel.
332, and we rated at what, 225?
225, yeah.
Whew, so it's making way more than rated.
Let's see if that makes that a little easier to see. There we go. So you can see, once again, we start pretty low, climb up in the THD when you make power, and then turn the corner. Yeah, so 332 watts, 4 ohm bridge. We could call this amp technically if you're gonna do 2 ohm power or bridge power, like a 600, 650 if you wanted to, but of course we're doing 4 ohm numbers, so yeah, it's a 404.
Wow.
So we need to keep that in mind when you're looking at models, is look at power at the impedance you plan on using them at.
Yes, yes.
Because this amp would be, a very good choice, especially if you're doing bridge or 2 ohm load. 2 ohm load would be, a lot of power.
And not everybody agrees with me, but I know you will, Joe, that if you've got the money, buy more power than you need, because you can always turn it down.
Yeah, I'm running I'm running this amp here to stock Bose 6x9s, some 3.5 with tweeters in the dash. So I'm running 125 watts to the dash speakers, and the door speakers happen to be 2 ohm, so they're getting like 270.
Yeah.
And I've had them like this for 9 months. As long as you're good with your tune, know what the limits of the speaker are and where it starts to fail.
Yeah.
I always like more power. My 3 Q-Class 10s are running off a 2401.
Yeah.
And have been for quite some time. So, I'm going to buy more power, because power makes a bigger difference as long as you use it effectively.
Yes, that's right.
And carefully. All right, so that was no problem. So we're going to go ahead and do a power bandwidth test. And then we'll do a time versus power test, which you should be able to see our amp hit power rollback and then thermal and then come out of thermal and do all the fun things that it needs to do. Let's see. So
this is the brutal test that killed the pizza box.
Okay, that's pretty good. It regulated, noise is good enough that it could do that. I need to change our scale.
So what are we looking at, Joe?
So here what you're seeing, THD right at 1%, right, and drops at the top. And now you see that we're pulling 378 watts through those output inductors. You see what started to happen here.
Okay.
We started to have a drop because you're starting to saturate those output inductors. But let's see what that is in dB, because that's what matters.
dB meaning the difference in what you're hearing.
Yeah, and so power's crossed, so let's find the 3 dB down point. So we're gonna say we're at 33, so we're looking for 30. So 30. So you hit 3 dB down where you could actually start to hear it at 10.5K.
3 dB down at 10.5,
Okay.
so yeah, 10.5 kilohertz. 3 dB downs. So again, your hearing isn't even going to hear that anyway. So
No, but this is what happens when you start saturating amplifiers, and it's stuff that you don't see in normal everyday testing, right? We're doing stuff here that's a little harder than what most people would run through their amps.
Sure.
We do this test and some of this other stuff, but a lot of people, that's not what they do.
Right.
So now we're going to do time versus power. So hopefully this amplifier protects itself.
Let's see if our design is good.
We're going to see, this is going to be, let's see, 400. Let's make that like 50. And then this needs to be, I think, 6. Volts, I don't want volts.
All right. You need some time, Joe?
Almost there.
Okay, because I got another.
Okay, go ahead. Go ahead and do another.
I got another third and final Jacob question for the night. Hi, I just purchased and installed a Kicker Key 204 with a factory radio. It was very successful install with the audio tuning done, and the sound was perfect for me. But now I'm trying to set the gain, and any turn clockwise will set the limiter lights to come on. I'm running a 20 to 20K sweep for the gain match. Need help or advice? So Joey's running the 20 to 20 hertz sweep.
Which is what you should do with a factory radio. So the issue you're going to run into there is when we do the key algorithm, we also adjust some gain. So if you wanted to do this to get the most out of it without clipping, you should probably clear it, run the 20-20 thing, turn the gains up until right below clipping, and then run the algorithm. And at that point, not touch it. The problem is going to be is when we have a DSP, the simple turning the knob to a certain voltage or turning the knob at one frequency goes away. Same thing when you're integrating with a factory head unit because they're not flat. So when we do our tune, they'll be up to 3 dB a boost on certain frequencies, which is quite a bit more power, as you know.
Sure.
And there'll be cuts. So setting it after we do our EQ will be very difficult. You really should do it before. Try to set your gains. I mean, we always ask you in the beginning to get them up to where they seem to be about right, but you could really go through, clear the tune, set the gains first, run the tune, and then not touch it. I mean, you got to remember it's a 54 watt amp by 4 at 4 ohms. If you need more output than that, you might need to,
get a 360.4.
Yeah, well, or 504 or something with quite a bit more power, because the difference between 50 watts and 70 watts you're not going to really hear. You're going to need to double your power, so you're going to need to go to something that's 100 watts by 4.
So in this install, the simple answer is clear the tuning, which is press and hold the button for 10 seconds. It wipes out the tuning. And then do the gain setup first, and then rerun the tune on the amplifier.
Yeah. The hard thing is how do you know when your factory head unit clips?
Yeah.
And that's what gets everybody, right? We recently had an install in-house here where one of the installers called up front saying, hey, the key's failing. And when you dig into it, the radio is at 1 click past like half volume or 2/3 volume, but it was clipped. So all the way in the bass range, because they had EQ on the bass, the head unit was clipping by half volume. You had to be like 1 or 2 steps under half volume to actually run the correction algorithm because the head unit was clipped. The only way to really see that is with an O-scope and our 20-20K sweep. It's slow enough that you can actually watch it on an O-scope and see when it squares off.
Yeah.
And if you see it square off, you turn it down a couple notches, wait for it to sweep again, see if it squares off, turn it down a couple notches. That tells you where your max radio volume is. Once you have that, then you can use that volume with the 20-20K sweep to set the limiter lights or the gain lights on the key amplifier.
And then you got to be disciplined not to turn the radio past that.
Yep. I mean, you'll have some music that's recorded lower, so you can get away with that. But you have to know when you start going above that, if the music is recorded hot, you're going to be clipping the inputs, clipping the actual head unit, and so the signal going into the key will be dirty.
All right, Joe, let's run that final test.
All right, so here we go. We're set up. We're all ready to go. Let me turn the outputs on. Amplifier's, nice and toasty already, so we're going to go ahead and go. And this is time versus power. I think if you saw, like the other one died here, about 100.
How long is this test?
Until it dies.
Oh.
Or until we hit thermal rollback and turn off and then turn back on, right?
Oh, okay. So this is testing how the amplifier handles thermal overload.
Yep. So this is being brutal, right? You're making max power out of the amplifier, constant, to a resistive load, which draws 30 to 40% more current than most speakers. It's pretty much the hardest test you can do. And you should see thermal rollback start to happen. So you kind of see here, we should start to see steps at some point, as long as this doesn't happen into thermal so fast it runs by the steps, which sometimes with these type of things, because it is so much more difficult on an amp than a real world, that they will jump past the thermal rollback side.
So how long has it been going now, approximately?
300 seconds.
Okay, and there's
a thermal rollback event.
Okay.
So we dropped down to 280 for power, 275 for power.
Was that about 3 dB?
Yeah, well, that's actually 1.5 dB. Our steps, we do 2 1.5 or 3 1.5 dB steps, and then a 3 B step, and then
so it's inaudible with music. You can't even hear it.
Yep.
Yeah.
Well, we've never been able to get them to do this with music, but
there's step 2.
Yeah, but if you're outside in the sun and it's 120 degrees in the desert, we want to make sure that this thing still survives for you.
Wow. That is tough. So now you're down about 3 dB.
Yep, about 3 dB down, almost 200 watts.
After how much time? 350?
340 seconds or so.
40 seconds, okay.
So to give an idea, in real world, this here takes 40 45 minutes to an hour to hit the first step, and we've never been able to get to the second step in our real world testing.
With music.
With music and a reactive load. So now we're down at the 3 dB step, right? So we dropped again. And at this point, it'll probably just continue to play forever.
Wow. That's fantastic.
So we'll go ahead and stop this test.
Don't touch the amplifier.
It's probably pretty warm. Let's see. Should be about 90 C. Yep, about 90 C.
All right,
hot
Joe.
enough you can tap, but not hot enough you want to hold on to.
Yeah.
So as you can see, both of these are half bridge amps. They were able to be bridged. So it's, and you know, SNR was greatly different. CMRR was greatly different. Reliability, as you can see, greatly different. So it's not about half bridge or full bridge. It's really about how the design is made and what the reliability expectations are of that amplifier.
So they both have their place in the car audio world. And basically, if you're looking for a high performance long-term amplifier, the Kicker is the clear choice between the pizza box and the Kicker.
In this case, I would say yes.
Yeah. Okay, well, great. Joe, any final thoughts before we let you go?
No, if you guys have any questions, let us know. We'd be happy to answer them. I actually enjoy this type of stuff. I've been a car audio person since I was like 14, so you know, hit us up, let us know if we can help, and we'll try.
Thank you, Joe. And Megan, thanks for giving us Joe for the night. We appreciate that. So go home and see your lovely wife.
All right, thank you guys.
Good night, Joe.
Good night.
All right, well, in the interest of time, let's do a couple more things together. We want to talk about some of the events. We just had a great event week. And can you pull up my laptop, Ernie? We did Mira. Wait, that's not Mira. We did Mira, which is kind of an industry show in Dallas. It's a Mobile Electronics Retailers Association. So it's not for consumers, but for people inside the industry, it's basically knowledge festival. It's where you go to learn. And of course, we had a setup there. And just a couple pictures. Ernie, pull up my laptop real quick. This is what you're looking at here is the Kenwood booth. So of course, Kenwood was there, Sony was there, and we're all just there to talk to our retail partners about new products, existing products, technology, techniques. And one of the best parts about these events is there's a lot of camaraderie. There's a lot of industry people that work for competing companies, but we're friends at the end of the day. And we're just hanging out, talking, and showing off our products. This is our booth, obviously. You can see our famous Fiat. That's been in the family for quite a while. And there's Jacob Lucky, our new guy. Jacob, woohoo! He did a great job at the show. But we're also showing a whole bunch of Kicker products. Almost everything that we offer current product-wise is on display in that booth. So that's a great show, and that was in Dallas. We also did Ocean City Jeep Week, and this is a consumer show. And what you're looking at here, of course, is the Kicker XRV, and Jeremy and Josh Alexander drove that out there for us to Ocean City, Maryland. And just go through a few of the pics, give you an idea kind of what our setup looks like. And this event's been going on for quite a few years, and we've participated in a big way for the last several years. There's some beautiful pictures of things that aren't car audio related, but some of the cars and the Jeeps, especially the Jeeps, because of course it's Jeep Week, some of these Jeeps are just crazy. There's a lot of Kicker love out there, of course, and we bring these guys and girls into our booth and show off their systems. And this is a 2 L7S15s in a blow-through enclosure and a Jeep Gladiator. He's actually designed the box, hopefully, for Solo X's, but as placeholders, he's got the L7S's in there, hoping that it'll be the same box dimensions. So a bunch of great pictures of the installation and some of the quality work these folks have done. So that was a great show. And then we also have upcoming the American Flat Track races right up here in Springfield, Missouri, not too far from here. Oh, Illinois. Thank you. Springfield, Illinois, the other Springfield, not where the Simpsons live. That's a different Springfield. And so that event's going on. And of course, we're a title sponsor of that. So if you're into big bikes going fast in a circle, this would be a great event for you to check out. We also have the Sand Sports Super Show in Costa Mesa, California. That's coming up. And that's a pretty big event that we like to talk about. I guess we don't have a listing here for that. But again, in Costa Mesa, California, this is an outdoor show for UTVs, ATVs, side-by-sides, off-road vehicles. Great event. We're going to be up there with a pretty heavy presence and just a lot of fun. So if you're in the area, please check it out. We did Jacob's questions. We always love the do not do this photos. So let's take a moment to do not do this photos, because these are just great. So here, the first one I like to call creative fusing. So you can see that this guy ran out of fuses, so he just put some bolts in places of the fuses, and just hope you're not using a pizza box amplifier with this installation, because you are going to have problems if you're using a pizza box amplifier. Here's a creative ground. There's a really good chance that this ground isn't doing much of anything. As you can see, not only is there a bunch of bare wire and some corrosion and rust, but it looks as though it's mounted to the carpet and not much more. This actually is an Ernie's Volvo. He sent us this because he's making fun of himself. He wanted to show us his creative accessory powers. These are probably running his gauge cluster or something in his Volvo. So yeah, there's some creativity going on there. So yeah, don't do that. Again, if these are your pictures like Ernie, thanks for sending them to us. And we don't want to make fun of you. We just want to have fun with you because, hey, we're all learning. So, all right, that's it. Oh, prizes. Oh my gosh, I almost forgot about prizes. Do we have some winners? As you know, third place winner, you get the koozies, you get the UnMasked t-shirt, and you get the EB400 Kicker earbuds. So, Bill, who is our winner number 3 tonight? Do we have that? Winner number 3, Reggie G from Georgia. Reggie G, Georgia, you're winner number 3. Thanks for playing. Winner number 2, who's number 2? Winner number 2 is Carlos P from Tennessee. Carlos, you get the, let's see, the Tabor 2s, the koozies, and the t-shirt. And winner number 1, who is 1 tonight? Simon S from Minnesota. Simon from Minnesota, thanks for playing. You get the Cush NC noise canceling headphones, the t-shirt, and a couple of koozies. Ladies and gentlemen, please, if you won, send us your information so we can get you your prizes. Thank you all for being here. Just to remind you, we're going to be on air in 2 weeks. Mr. John Myers is going to be back. And next Tuesday, you've got Living Loud with Andy on YouTube and Kicker Club on Facebook. So spend some time with Andy next Tuesday, because we're going to be out in the field doing our magic. So Andy's going to take up a night for us, and then the following Tuesday we'll be back. Ernie, I'm going to wrap it up, so get ready with the button. Ladies and gentlemen, thank you very much for being here. We appreciate your time and your attendance, and we'll see you next time.